Hello everyone, welcome to Learn. I'm here with Albert today. I'll be keep going with our discussion on nuclear energy. So for today, let's talk about what if the best possible nuclear fusion reactor was to be built in the future. But before that, let's talk about why we still haven't gotten to that point yet. We're actually facing a lot of difficulties in inventing a self-sustaining and long-lasting fusion reactor, while allowing its output energy to be bigger than its input energy. And I have mentioned some of these difficulties in our last video, and I will be going into some of it in a greater detail now. Difficulty number 1. Damage to the reactor brought by energetic neutrons. In order to produce usable heat in a magnetic confinement fusion reactor, the neutron streams carrying around 80% of the energy from deuterium-tritium fusion must be decelerated and cooled by the nuclear reactor's structure and its surrounding cooling systems as well. However, the neutron's radiation damage to the solid wall of the inner of the tokamak is far more worse than what we can possibly imagine, and this caused some issues. For example, we cannot sustain the nuclear fusion reaction for a long time, since by doing so the entire inner wall of the nuclear fusion reactor will be destroyed and some possible, explosions might happen. Difficulty number 2. Radioactive waste resulted from bombardment by fusion neutrons. Again, in a magnetic confinement fusion reactor, bombardment by fusion neutrons to the inner wall of the tokamak knocks atoms out of their structural positions, making them radioactive and weakening the structure. This means the inner wall of the tokamak must be replaced periodically, and therefore will result in a huge mass of heavily radioactive materials that must be transported to somewhere for burial. While although the radioactivity level per kilogram of the wastes would be much smaller than those of the fusion reactor's wastes, the volume and mass of the wastes will be many times greater. And that's a pretty big issue actually. Difficulty number 3. Replenishing tritium fuel. The deuterium-tritium reaction is favored by a lot of fusion scientists because its reactivity is about 20 times higher than the deuterium-deuterium fuel reaction, and the former reaction is actually the strongest at only 1/3 of the temperature required for deuterium-only fusion. Although deuterium is quite common among ordinary water, tritium almost does not exist on Earth. You could probably find only a few grams of it in the entire Earth. This was because that this isotope was quite radioactive with a half-life of only around 12.3 years. And the main source of tritium is therefore fission nuclear reactors. This basically means that we cannot get tritium easily and therefore sustaining our nuclear fusion. Now, let's get into the main topic of today. Let us imagine what if we somehow solved all of these difficulties one by one and made the perfect fusion reactor. What would happen then? The first thing that came to our mind was that the electricity produced by this perfect nuclear fusion reactor would be almost unlimited, and it would be also very, easy to produce. And we can therefore make an analogy to the internet usage these days. Back in the early days of the internet, you see the access to information was quite hard and it's quite expensive as well. But now, as our technology gets better and the satellites move around and GPS goes everywhere, it is actually quite simple and cheap for us to search for anything online. Like this video you're watching, it's not that costly at all. So if you develop upon or look into this idea deeply, you'll realize that any issue that deals with energy consumption would be solved. For example, back in the old days when agricultural economy was still a thing, people were pretty vulnerable to floods and droughts and other types of natural disasters that could destroy their crops. But now that we have all these energy in the form of electricity produced by our nuclear fusion reactor, we can actually do all the agricultural stuff in a monitored greenhouse, which means that agriculture will be no longer affected by natural season changes and natural disasters. Then with this abundant supply of food and energy, we can actually be freeing human labor to the next level allow for maybe another few levels of workforce, I guess. Things like creative works, like art. Maybe that's the time for another renaissance or romanticism period. Also, as a clean energy, our nuclear fusion reactor does not emit any greenhouse gases nor produce any radioactive wastes. And therefore, we have the enough amount of time and apparently enough amount of energy again to slow down global warming and probably even reverse it to make our planet more habitable by humans and to kind of colonize every corner of the earth. Now, we've solved all of these problems, and our future just seems so bright and happy. But remember, in reality, we're still facing all of these difficulties when it comes to inventing the perfect fusion reactor. And solving these difficulties one by one is probably a job for someone like you, the one watching this video. And that is the end of our nuclear energy series. So thank you for coming to Learn, and I'll see you next time.